Hello, this is Team 1121. It's Ryan Spitzer, Connor Wiggins, and William Rawlings. We're doing Problem C, Birds of Different Feathers, and we are from the Florida Institute of Technology. So the problem that we are working on today is that species tend to herd either solely with organisms of the same species, or they will sometimes venture out and spend time with other species while feeding. And what we were tasked with is coming up with a mathematical way to show whether or not there is a benefit of doing this. So in order to do that, we need to make some assumptions. Um, the first assumption that we made is wherever the prey live, the predators also live in the same areas. This is pretty true for every predator prey system in the world. The next one we made is that any species is equally likely to be pursued by the predators. So the predators do not take a liking to one form of prey over the other. And the last assumption that we made is hive intelligence, whether or not, or sorry, when one organism is aware of the predator, the entire herd knows. Basically, if one species in the herd is capable of detecting a predator, then every species in the herd will know, which will prove beneficial for the purposes of this problem. So defining the variables in the equations that we made, we decided to let P of t be the probability of detecting a predator at time t, and the function lies between 0 and 1 at all times. 1 being like 100% chance of detecting a predator, and 0 obviously being 0. So we decided to let y of t be the predator abundance. The more predators, the more likely they are to be detected. A of t being the prey alertness. The higher vigilance leads to faster detection. And when a equals 1, the prey are perfectly alert. They will always know when predator are in the area. And we decided to let v equal visibility. Obviously, like if there's dense vegetation, say they're in a jungle, there would be a slower detection time. So when v equals 1, prey would have perfect vision of their surroundings. So it'd be very easy to spot their prey or predators.
This is the differential equation that we came up with. As the previous slide stated, all of the variables still represent the same thing. And now we have an added on alpha and beta, where each of them represent coefficients to some response or relaxation of each species. We solved for the steady state by setting the differential equation equal to 0 and solving for some probability denoted by P star. This is the result that we came to. Just some simple facts to show how our equation is accurate. You can notice as y of t increases, our probability will approach the determined P star. And you can also notice as y of t goes to 0, the differential equation approaches negative beta times the probability. This shows that the probability of detecting a predator will decrease when no predators are around, which is pretty intuitive. We also want to assume that each detection chance is an independent event, hence the probability of one occurring does not affect the result of the others. This will be crucial in helping us solve the problem when more species are present. When we add in multiple species, we add a sub I to each of our variables to show that each species will have their own probability, alertness, visibility, and coefficients. We also want to solve this in the same way that we did before, reaching the same result.
This is of course true as long as each detection chance is an independent event. Notice that P sub I is small. If P sub I is small, then P sub G is approximately the sum of all the individual probabilities. Also notice if P sub I is large, then P sub G is approximately equal to 1. Using MATLAB, we created a graph to show our function. We assigned the following randomly generated values to show that the probability will increase as more species are added. The following values are subbed in to the P sub I equation. Alpha equals 0.4, A equals 1, V equals 1, and beta equals 0.5. And from there, P sub I is subbed into P sub G, where we use that graph to model P sub G. The more species you have in an environment generally will produce a higher probability of detecting a predator. This was also in agreement with the article given about zebras in the plains of Africa. When feeding with other species, they spent less time alert and more time relaxed. Here's our source.